In this Gold Belt video, I will show how to test a background service in Python. I have the project open in Visual Studio Code. This is for the test existing functionality background service. So if you want to open up the code and follow along, you're welcome to do that. The background service in Python is interesting. So this particular one, let me open up what we're doing here in main. We're using this Win32 service package. So that's the library we're using to try to make all of this work. So this one's interesting because really there's not a way to take this class that derives from service framework and mock it out directly. The class itself wants to be run in a Windows 32 process, and our tests do not do that. So what we're going to need to do is do a little refactoring in the code. So it's a little dangerous. We're going to work without a safety net a little bit. We're going to try to minimize the amount of code changes, but we need to refactor this class just a touch, create a new class to be able to test it. So let's get started with what we need to do. Well, as typical, we want to start off with our testing framework. So let me just run pip-env shell. Need to install our dependencies. Let me see what we've got. So no deb packages yet. Pip-env install dev. So we'll install all the dependencies real fast. And let me go ahead and see if I can use, my transaction loader environment. There we go. So make sure that's up and ready to go. And I'm going to use pytest. You're welcome to use unit test if you want. It won't make a difference. It's really just around running the tests themselves. So I'll install pytest as a dev dependency. And let's create our folder. This will be transaction loading test.py. Let's create our method, transaction loading, and this is test underscore transaction loading. We'll say this is our success. All right, so our goal is to be able to test this object, test this class. So if I start off with the transaction loader, it'll take self and args, and I can go down that path. It's going to be a fruitless path. So I'm not going to waste the time here. Trust me, you're welcome to try it, and it's basically pretty simple. All I would need to do is say from source.main import transaction loader service. And now I could say create a new transaction loader service and service.svc run or do run. So let's go ahead. Let me just show you what's going to happen here. So we'll run our tests. I'll go and run this through the runner. We'll configure it for pytest. Nope, not what I wanted to do. Test folder. Oh, I do have an error. Let's see. This is probably an import. Let me go to main. Yes, this needs to be source.transaction loading. All right, let's get back to our tests. Yep, there we go. Okay, so let me go and run this. Boom, errors out, and it's erroring out. The service name is not hosted by this process. All right, so you're going to run into this problem where, okay, well, maybe I put the service name in. You could try that. That doesn't work. So if I just pull this in, that doesn't work. Run the test. Same error. Same error. So effectively, the problem we're running into is this particular class, which derives from service framework, simply cannot run in a Python testing process. It has to run in a Windows 32 Service Process Manager runtime or process. So this is just a non-starter. We really can't we can't run this way. So what are we to do? What are our options here? Effectively, if we look, we're looking for our main method. Well, here it is. It's called main. So that's great. So this is our main loop. This is our forever loop. While should be running, and we'll notice should be running is just on self, right? So it's defined on this thing. Effectively, what we want to do is we want to be able to test this code without necessarily creating the whole class. So this is where our refactor is going to come in. What I'm going to do is I'm going to delegate this to a new class. We're going to create something else that we're going to call from main. So let's write out what that code would look like first, and then we'll figure it out. I'm going to call this a runner. So this is the actual runner. You can call it a loop. You call it a loop, whatever. The name doesn't really matter, but I'm going to call it a runner. And this is going to be a new transaction loader runner. Now, to it, what I'm going to give it is how does it know it should be running? And I'm going to just give it a lambda. So I'm going to say lambda self should be running. So this lambda is a function that will evaluate to self.should be running. And so this way I can decide, I can use start and stop and whatever I need to do to basically say you should run or you shouldn't run. So that's what I'm doing here. So instead of just giving the value directly, I'm giving it a lambda so that it can evaluate that each time through the loop. Oops, that's not here. That should be here. Sorry. So runner, given a transaction loader runner, give it the lambda. And then from here, all I'm going to do is say runner.run. And that's it. The self dot should be running is going to automatically turn off to false whenever it needs to. And so this loop will automatically close whenever things happen. So all the rest of this is going to go away. What we're going to do is I'm going to comment this out for now, but we're going to copy this into our new class. So I'm going to define this class up top here. Transaction loader runner. I'm going to let it help me. I don't know if it's going to be right, but let's see. So we'll say constructor. Should be running. These are our methods. Run self. Okay, so that looks good. And let me just paste what we had. So these are the lines that I just pasted straight in. The only difference that we're going to do here is this callback. So this should be self dot should be running callback, and we're going to invoke that lambda. We're going to invoke that method. If that returns true, we'll continue on. If it returns false, then we stop. But otherwise, this code is exactly the same as what we had down below. So this is our refactor. So again, we're taking the existing code, we're moving it into a new class, and then pulling it up here. Now, why did we do that? The reason we did that is because this is the class we're going to use in our test. So let's go back to our, well, save. Let's go back to our test real fast. And now we're going to import the runner class. So now my runner will define should be running equals true. So we'll start off with true. And now let's create our runner. So our lambda in this case is just returning the value of should be running, whatever that value is. Runner.run. Now we're off. We're started. And now when I'm ready to stop it, I can simply say should be running equals false. I could do assertions or checking here. So work can go here. I can also say additional work here, right? So these could be assertions, these could be checking on database connectivity things, whatever I need to do, but this is the basic structure now. So now that I've done that refactor, the existing code should continue to work, and it is worth testing actually, since again, we're making changes without a safety net. So it's good to actually install this in the service manager and make sure, but now we've got the ability to start and stop it. Let's run through. If I did this successfully, we should get a database connectivity error. Let's see what happens here. So we do get an error. Yep, could not find host name prod data 02. So we are now having the problem that we hope to have, which is we've tested the service functionality. We're now on to the database side of things, which is a separate video. So again, that's the idea here. And this approach can work in other languages as well, where you can refactor things. So in the other videos, I go through some very specific things around those languages. But if you can find that main method and decouple it from the thing that you simply cannot test, this gives us the ability with this class now to test the actual functionality we want. Now let's also confirm real fast. Let me set the should be running to false. I really shouldn't, it should just close out and succeed because it's never trying to connect to a database. Sure enough, it does. So now I can actually verify that this thing isn't running. I can set it back to true, and we do get our database connectivity error. That's basically it for the Python side of things. So good luck on your journeys.